All right, today we are working on discrete probability distribution. This is chapter number 5. We are going to begin with some basic idea about the probability distribution. So here, first thing we want to talk about is something called a random variable. When I say a random variable X, it is a numerical value associated with each outcome of a probability distribution. So for example, if you are tossing a coin, you'll get either a head or a tail. So that head or a tail is a random variable. Next example, if you roll a six-sided die, your outcomes are 1, 2, 3, 4, 5, and 6. These numbers, 1, 2, 3, 4, 5, and 6, these are random variables. One more example, suppose you are answering a true or false question. Your result is either true or false. So that true or false is an example of random variable. So whenever we say random variable, we denote it by uppercase letter X, is a numerical value associated with each outcome of probability distribution. And this random variable, they are of two types. One is called the discrete random variable, and the other one is called the continuous random variable. First, let's talk about discrete random variable. A random variable X is discrete variable if it has finite or countable number of outcomes. The outcome of the experiment, if they are countable, if you can count like 1, 2, 3, 4, and so on, then we say that the random variable is discrete. For example, number of calls made by a college professor to his student in a day. So if you want to record this, how many calls are made by a college professor to his student in a particular day? Maybe he made a 5 calls or 7 calls or 8 calls. It will be a counting number. So if it is a counting number, not a decimal value, then we say that it is the discrete variable. But the other one is called the continuous variable, and that is a random variable X is continuous if it has uncountable number of outcomes, or in other words, the random variable is continuous if it includes even the decimal values. Example, number of minutes spent by college professor while calling his student in a day. How many minutes are spent on the phone? Maybe 2.3 minutes or 7.8 minutes or 2.9 minutes or 10 minutes. So when we talk about the number of minutes here, it can also take the decimal values. So if it can take the decimal values also, then we say that the random variable is continuous random variable. Now let's talk about discrete probability distribution. Discrete probability distribution consists of values of random variable and their properties and their probabilities. So whenever we are talking about the discrete probability distribution, this is the probability distribution of the random variable. And there are two properties that it has to satisfy to be the probability distribution. The first one is the sum of all probabilities must be 1, and the value of each probability is between 0 and 1. What does that mean? Let's take an example here. For example, the probability distribution of number of heads on tossing 3 coins is given here. How many heads you'll get by tossing 3 coins? No head, suppose the probability is 1/8. 1 head, probability is 3/8. 2 heads, probability is 3/8. 3 heads, probability is 1/8. So here we have the probability distribution given. This is called the probability distribution. But for this distribution to be probability distribution, it has to satisfy two important properties, and we are going to check that. The first one is sum of all probabilities. Sum of all probabilities must be 1. Let's find it. So these are the probabilities. We have 1/8 plus 3/8 plus 3/8 plus 1/8. So it is 1/8 plus 3/8 plus 3/8 plus 1/8. You have a common denominator of 8. Now if you add the numerator, 1 plus 3 is 4, 4 plus 3 is 7, plus 1 is 8. So it is 8 over 8, 8 over 8, which is equal to 1. So the first condition is true. Sum of all probabilities is 1. So this condition is true. Now, second condition is the probabilities, the values of probabilities must be between 0 and 1. So if you look here, this is more than 0 but less than 1. This is more than 0 but less than 1. This is more than 0 but less than 1. This is more than 0 but less than 1. So all these probabilities are between 0 and 1. Okay, all P of X, the probability of X is between 0 and 1. All these values are more than 0 but less than 1. So they are between 0 and 1. So these two conditions are true. Meaning of this one is this distribution that is given here is a probability distribution. This is a probability distribution. And in this probability distribution, if you look at the random variable is taking only the discrete value, no decimal values. So your X is a discrete random variable, 0, 1, 2, 3, and so on. So this probability distribution is a discrete probability distribution because the random variable is discrete, it's not continuous. Example, suppose X is the number of heads while tossing 2 coins. We have to construct a probability distribution for the random variable X and represent it graphically. Okay, so X is the random number or a random variable which represents the number of heads while tossing 2 coins. So let's see what are the possibilities. When you toss a coin, on the first coin you will get a head or a tail. On the first coin, you'll get a head or a tail. Similarly, on the second coin, you'll also get a head or a tail. So the possible outcomes are, the first outcome will be, you'll get head on the first and head on the second. So head, head. Head on the first and tail on the second. So that will be head, tail, head, tail. And here, tail on the first and head on the second, tail, head, tail on the first and tail on the second, tail, tail. And here we are looking at the number of heads. We are looking at X is the number of heads. So if I want to write how many heads are there, here, if you look at this one, we don't have any heads there. So 0 heads there. And then here and here, we have 1 head, 1 head, 1 head, 1 head. And then here we have both heads, 2 heads. So these are the X values. X is equal to 0, 1, 2. So these are the random variables. X is the number of heads. So you'll get no heads, or you'll get 1 head, or you'll get both heads when you toss 2 coins. Now, if I want to find the probabilities, we write Px. Now, probability of getting no heads. Here we don't have any head, and this is 1 out of 4 outcomes. So out of 4 outcomes, we have 1 of them. So 1 out of 4, or 0.25. 1 over 4 is 0.25. Similarly, 1 head, if you look at 1 head, here is 1 head, here is 1 head. It occurs 2 times out of 4. 2 over 4, or half. That is 0.5. And then 2 heads, both heads. Here we have both heads. That is 1 out of all 4. 1 over 4, or 0.25. So we have this distribution of random variable along with the probabilities. We have the random variable and also the probabilities. And here, if you look at this, if you try to find sum of all probabilities, if you add this, you have 0.25 plus 0.5 plus 0.25, which is equal to 1. Okay, 0.25 plus 0.5 plus 0.25, that's equal to 1. And also, you can see all these probabilities are between 0 and 1. All probabilities are between 0 and 1. So this is the probability distribution of number of heads while tossing two coins. So after we have constructed the probability distribution for the random variable x, we are asked to represent it graphically. When we represent the probability graphically, we try to draw the histogram. So let's try this. Along the x-axis, we'll have the random variable, and along the y-axis, we'll have our probabilities. So we draw the x and y-axis. Along the x-axis, the random variable x, which is 0, 1, 2. I'm going to label that 0 here, 1 here, and then 2 here. And then along the y-axis, we need the probabilities. Maximum probability will be 1. So let me do this. This is 0.5, let's say, and this is 1. So 0.25 will be here. And if you want, 0.75 will be here. So we have the probabilities along y-axis and the random variable along x-axis. Now we draw the histogram. So we have to draw the bar which are joined to each other. The first one has a probability of 0.25. So you can draw a bar of height 0.25. So this is the probability when x equal to 0. Probability is 0.25. Next we have 1 and the probability is 0.5. 0.5 or half. So that is for 1. Probability is 0.5. We draw the bar there, which is joined. When the bars are joined, then that is the histogram. And the last one is when the number of heads is 2, the probability is 0.25. Number of heads 2, probability 0.25. This is 0.25. So this is how we can represent the probability distribution graphically, because this graph will tell you whether the distribution is left is skewed, right is skewed, or normal. In this one, you can see we have a tallest bar in the middle, and we have equal amount of data on the left and right of that. So meaning of that is this distribution is a normal probability distribution. Example, determine whether each of the following distribution are probability distributions. So here two distributions are given, and we have to check whether they are probability distribution or not. What we know is for the distribution to be probability distribution, okay, for a distribution to be a probability distribution, the first one is the sum of all probabilities must be 1, and the second is the probabilities must be between 0 and 1. If these two conditions are true, then we say that it's a probability distribution. So if we look at the first one, let's find out. For part A, sum of probabilities is equal to, okay, let's try to add the probabilities. 0.1 plus 0.2 is 0.3. That becomes 0.4. 0.4 plus 0.4 is 0.8. 0.8 plus 0.3 is 1.1. Okay, it is 1.1, not 1. It's not 1. If it is 1, then we'll go to the next one to check. But here we saw that the sum of the probabilities is not equal to 1, although these probabilities are between 0 and 1. Here you can see all the probabilities, okay, all the probabilities are between 0 and 1. These values are between 0 and 1. But if you add, it is not 1. That means this is not a probability distribution. This is not a probability distribution. This is not the probability distribution. In part B, if you look at these probabilities, we have 1 over 4, 1 over 2, 1 over 8, 1 over 8. All these values are between 0 and 1. So here, the probabilities are between 0 and 1. Probabilities are between 0 and 1 because all these values are between 0 and 1. And also, if you try to add, let's see what we get. If you try to add, see here we have 1/4. 1/4 is same as 2/8 because I want to make a common denominator while adding. This is 1 over 2, which is same as, if you want to make 8 as the common denominator, it will be 4 over 8. That will be 1 over 2. Then we have 1/8, and also we have 1/8. What I did is I'm making a common denominator. 1/4 is same as 2/8 because if I multiply both numerator and denominator by 2, that'll be 2/8. If I want to make 8 in the denominator, I have to multiply both numerator and denominator by 4. So that's 4/8. So by adding this, let's see what we get. If we add all this, we have a common denominator. 2 plus 4, 6, 7, 8. 8 over 8 is equal to 1. So here, both conditions are true. All probabilities are between 0 and 1. And sum of probability is also equal to 1. Meaning of that is, this is a probability distribution. So we can write, this is a probability distribution. Okay. Example, fill in the P of x equal to x. That is, here there are two blanks. We need to fill this table, okay, to give a legitimate probability distribution for the discrete random variable x, whose possible values are 1, 2, 3, 4, 5, 6. So they have given these probabilities. We have to have these two values so that it's a probability distribution. So what we know is, for this distribution, to be a probability distribution, what we know is all probabilities must be between 0 and 1. All probabilities must be between 0 and 1. That is, all these values, this one, these are already between 0 and 1. So all values must be between 0 and 1. That is the first thing. Also, if you add all these probabilities, this sum means adding. If you add all these probabilities, that must be equal to 1. Now, we don't know this one. When x equal to 1, we don't know what is that probability. Probability when x is equal to 1, I don't know what is that. Plus the second one, probability when x is equal to 2, I don't know what is that. But plus, if I add these, if I add 0.14 plus 0.25 plus 0.20, that is 0.59. I know that is equal to 1. So the probability in the first place, this one when x equal to 1, probability in the second place, then all these probabilities when you add is 0.59 and the sum is equal to 1. So what we get is probability when x equal to 1 plus probability when x equal to 2 is equal to, now you can subtract 0.59 on both sides to get 0.41. 0.41. So what you have to do is, there are multiple answers for these two positions, but what is true is, when you find these answers, these numbers must be between 0 and 1, and the sum must be 0.41. So meaning of that is, one possibility that I'm going to show you is this. If probability when x equal to 1 is 0.40, then this one must be 0.01. Because 0.40 plus 0.01 is 0.41. So that is one possibility. So I can write like this: probability probability when x equal to 1, and probability when x equal to 2. I'm showing one possibility. One possibility is it can be 0.40 and 0.01. That's the correct answer, because if we add those two, it is equal to 0.41, and it is between 0 and 1. You can give any set of possible answers. The other can be, for example, to get 0.41, it can be 0.20 and 0.21, because 0.20 and 0.21 is 0.41. So there are so many possibilities, but what I'll be looking for in the exam is just one possible answers. So this is how we can find the missing probabilities in a given probability distribution. Mean, variance, standard deviation, and expectation of discrete probability distribution. In any probability distribution, we'll try to find the mean of the distribution. We'll try to find the average, also called the expected value. So they are the same thing. Mean, average, and expected values are the same thing. Okay. We'll try to find the mean, variance, and standard deviation of the distribution. So for the discrete probability distribution, there are a few formulas that you need to remember. For discrete probability distribution, the mean, which is also called the expected value, okay, mean or the expected value, they are the same thing, of the discrete probability distribution is given by this formula. It is mean is equal to sum of x multiplied to p of x. Sum of x multiplied to p of x. If I use the word mean, I use the symbol mu for mean. But if I say the expected value, although the formula is same, I represent the expected value by ex. So expected value is equal to sum of x multiplied to p of x. And then the variance is given by this formula. Variance is the square of the standard deviation. So variance is equal to sum of x minus mean quantity squared multiplied to p of x. So the standard deviation will be square root of this one, square root of the quantity on the right. So if you take the square root, that is the standard deviation. So this is your standard deviation. Example, let x be a random variable with the following probability distribution. So here is the probability distribution for x given. We have to find the expectation or expected value, which is same as the mean. And also we have to find the variance for this distribution. So what we know is, let me write the formula. The mean or the expected value for the discrete probability distribution E of x is equal to sum of x times p of x. If we multiply x and p of x and add them together, that is the expected value. And the variance is the square of the standard deviation is equal to sum of x minus mean squared, mean or expected value, they are the same thing, times p of x. So what we are going to do is, first we are going to use this distribution to find x times p of x. So x is given to you, p of x is given to you. I am looking for x times p of x, because in order to find the expected value, I have to find the product and add them together. So first one is 10, probability is 0.05. And if you multiply 10 times 0.05 is 0.5. 0.5. The second is 20 and the probability is 0.7. 20, probability is 0.7. If I multiply 20 times 0.7 is 14. Next we have 30 and 0.15. 30 and 0.15. Now if I multiply 30 times 0.15 is 4.5. You can check these values in your calculator. Next is 40 and the probability is 0.1. 40 and probability is 0.1. So 40 times 0.1 is 4. Now I'm going to add them together. Total. Because in order to find the expected value, we have to add x times p of x. X times p of x, we need to add them. 0.5 plus 14 plus 4.5 plus 4, that is equal to 23. So meaning of that is your expected value. So we can say the expected value or the expectation as it is said in the question. Expectation denoted by E of x is equal to sum of x times P of x. Then we got the result as 23. So that is the expectation. So next we have to find the variance, and variance is sum of the random variable minus mean squared multiplied to P of x. So we have to find this quantity and we have to add them together. So what I want to find here is x minus mean. X minus mean. Mean here is 23, mean or expectation. 23 squared. Then multiply that by P of x. So the meaning of that is, let's go to the first one. X is 10. So it will be 10 minus 23 squared multiplied to P of x. Our probability is 0.05. 0.05. And that is equal to 8.45. Okay. 10 minus 23 is negative 13. Negative 13 is squared is 169. Multiplied to 0.05 is 8.45. Now we'll go to the next one. That is, my random variable is 20. So it will be 20 minus 23 squared multiplied to, the probability in this case is 0.7. 0.7. That is equal to 20 minus 23 is negative 3. Squared of negative 3 is positive 9. 9 times 0.7 is 6.3. 6.3. So that is the second one. Now we go to third. Your x value is 30. So that is 30 minus 23 squared multiplied to 0.15, which is equal to 30 minus 23 is 7. 7 squared is 49. 49 multiplied to 0.15 is 7.35. 7.35. And the last one here, which is 40 minus 23 quantity squared multiplied to 0.1. So if you simplify this, your result is 28.9. So what we did here is we found the value of x minus mean squared multiplied to P of x in each of these cases. Now, our variance is the sum of all those values. So we are going to add these 8.45 plus 6.3 plus 7.35 plus 28.9. The sum is equal to 51. So we can say we are asked to find the variance. Okay, so variance, which is denoted by sigma squared, is equal to 51. That is the variance. If you were asked to find the standard deviation, you'll take the square root of this one. If you find the square root of 51, that will be the standard deviation. But in this problem, we are not asked to find the standard deviation. We are just asked to find the variance. So we add them together. That is the variance. Example, at a raffle, 1,000 tickets are sold at $3 each for 4 prizes. And the prizes are $500, $300, $200, and $100. So total of 1,000 tickets are sold, and the price of each ticket is $3. So if you get a $500 gift on that, or if you win $500, actually how much you are gaining is 500 minus 3 because you already paid $3 for that. So when you win $500, you are actually gaining $497 because you already paid $3 on that. The next one, if you get this one, if you win $300, you're actually getting 297 because you already paid $3 on that. If you win $200, meaning of that is you are getting $197 because you already paid $3 for that. If you get $100, meaning of that is you are actually winning $97 because you paid $3 for that. And if you are not getting any of these prize, you are losing your $3. So that is what is the meaning of this one. Now what you have to do is we have to find the expected value of gain if you bought one ticket. So let's assume that X is the gain on buying one ticket. X is gain on buying one ticket. Remember one thing, they sold 1,000 tickets, but they are giving back the prices to only 1, 2, 3, 4 tickets. Only 4 tickets are getting the prize. 996 tickets are losing. So if I want to write the gain X in dollar, the gain are, the first gain, if you win $500, the gain is $497. If you are winning a $300 ticket, the gain is $297. If you are gaining a $200, if you get a $200 gift, or if you win $200, the actual gain is $197. If you win $100, your actual gain is $97. And if you don't get any of these prizes, that means you are losing $3. Losing, so minus 3. Now let's also find the probabilities for each of these so that our probability distribution will be ready. So let me draw this table here quickly. They are giving one $500 ticket, a prize of $500. Okay, they are giving one ticket, or to one person, they are giving $500. So 1 out of $1,000. So, or 1,000 ticket, 1 out of 1,000 ticket. That means somebody is gaining $497. And if you want to know how many are gaining $497, only one person, only one out of 1,000. They are giving one $300 gift. That means 1 out of 1,000. One $200. So 1 out of 1,000 is gaining that. And 1 out of 1,000 is gaining that $100. When I say gaining $100, the actual gain is 97. So only these 4 are gaining. Out of 1,000, 4 of them are gaining. So 996 of them are losing. 996 out of 1,000, they are losing their $3. So this is the probability distribution for the gain when you buy one ticket. So once we have this probability distribution, we are asked to find the expected value of gain. So if I want to find expected gain, which is denoted at EX, you know that the expectation is the sum of X multiplied to P of X. We have to multiply X and P of X and then add them together. So meaning of that is, for example, if I multiply these two, see, we are multiplying and adding them together. So 497 multiplied to 1 over 1,000. So 497 multiplied to 1, 497 over 1,000. So I can write that as 497 over 1,000. Then plus 297 multiplied to 1 over 1,000. That is 297 over 1,000. Then plus the third one is 197 multiplied to 1 over 1000. That is 197 over 1000. Then plus 97 multiplied to 1 over 1000. That is 97 over 1000. And here the result will be negative. We are multiplying negative and positive. So it will be minus, and then 3 multiplied to 3 times 996 is 2988 over, you have 1000 over 1000. So this will give you the expected gain E of x is equal to 497 over 1000. You can write this as 0.497 plus 0.297 297 over 1000 plus 197 over 1000 is 0.197 plus 0.097, then minus, when you divide this, 2998 divided by 1000 is 2.9888. So this implies the expected gain is equal to, if you simplify this, if you add all these values and subtract that, that is equal to negative 1.9. That means on the average, you lose $1.9. So there is expected loss. Let me write that conclusion. There is expected loss. Negative means loss. There is a negative sign, meaning of that is loss of $1.90 by buying one ticket. So if you just buy one ticket, then you should expect to lose $1.90 on average. So if you want to gain, meaning of that is you have to buy more tickets. If you buy more tickets, there are chances that you'll gain something instead of losing.